Hello, everyone, and a warm welcome to today's webinar of the Elsner Academy. It is 10 a.m., so we get right into the topic. Today's webinar is about individual room control and efficient heating with KNX. I'm your speaker today. My name is Bastian Elsner and I'm managing partner at Elsner Elektronik. My main responsibilities are marketing, sales, product development, production, purchasing, logistics, and service. It sounds quite a lot, but I have a wonderful team around me that is supporting me with all those different things. So as a quick introduction, I have a question for you. So this morning, when you left the house to work, if you're not working in the home office, did you turn down your heating this morning when you left? Just a very quick and simple question. Feel free to answer in the chat. Maybe also while you're typing an additional information, today's webinar is live. So I kindly ask you to make use of this. Let's make this as interactive as possible. I'm here and more than happy to answer your questions. I also have Frederick in the back who can assist me if I don't know everything, so we can have a chat and give you the best possible answer. All right. I would make a guess. Most of you probably did not turn down the heating system if it's not automated. Another question. What do you think is the comfort temperature, is it subjective? I think this little draft, this little picture shows that what we all know, because I think everyone is familiar with the situation shown in the photo. The perception of warmth is very different from gender, for example, but also from person to person. Nevertheless, comfort can also be achieved with comparatively low room temperatures. To do this, some things should be avoided. For example, the drafts or huge temperature differences, because this is perceived as unpleasant to most people. Let's get into the learning goals for today's webinar. So after today's webinar, you will be able to determine the optimum temperature for different rooms in a different house. You learn how to apply the principle of individual room control, and you will learn how to distinguish between the different modes of operation of the control types and how to apply them correctly. Also, we will be showing some of our products and try to teach you how to select the right room controller for the right project. Next up, our agenda. First up, we look at the optimum of different room temperatures, because as said in the introduction, this can vary from person to person. Next up, we will discuss the principle of individual room control. After that, we'll have a look at the different control types, like for example, the 2-point heating or the continuous controller and the PI control. Next up, we will learn about the room temperature controller with operating mode changeover. So the switch point changeover in the controller itself. Afterwards, we have a look at the 2-stage heating. Next up, we will have an overview of Elsner Elektronik's KNX room controllers that can help with the topics we will discuss beforehand. Next up, we're gonna have a look at some practical examples and the parameterisation in the ETS itself. This has been a request after the last webinar that we should dive a little bit deeper into the ETS topics. So I would say let's get into the nitty-gritty and start with the optimum for the room temperatures. Just one thing, Frederick just reminded me, today's webinar will be recorded. So even if you have a meeting later on in 15 minutes and half an hour, don't worry. Since you have been registered to today's webinar, we will send the recording and also the slides in PDF format after today's webinar, fully automated. So please also keep that in mind for future webinars. Even if you cannot attend, it's very good to register because you will receive all the contents and you can re-watch the webinar per your convenience. All right, So before we deal with the actual regulation of the room temperature, we need to look at the different temperature ranges in the actual building. So we made a little graphic here, a visualization on how the room temperature should be changing from one room to another. For example, the right room temperature has a major impact on our well-being. So the optimum room temperature really varies depending on where you actually are. For example, in the office, the bedroom, the living room, or the fitness room. You should be having different temperatures for those rooms so you have the optimum well-being and optimum comfort. For those who feel very comfortable in their surroundings, they are more energetic and they're more productive. So this is also really good in an office setting. So here we gave you a small overview of the most frequently and used temperatures in the different areas. So for example, in the living room or in the study, we have a temperature of between 20 and 22 degrees. If you look at the hallway or the bedroom, the temperature drops between 16 to 18 degrees. That might seem a little low for some people, but according to several studies, this is actually the perfect temperature where you have the best sleep and the best recovery. All right, let's get into the principle of the individual room control. So here we see a schematic diagram of a room temperature controller. The room temperature controller shown in the box on the left records the room temperature and sends a manipulated variable to a valve or an actuator. The control valve is approached as a percentage, for example, in 40%. This means that the water then flows through the valve, or through the radiator and heating circuit and releases the heat into, into the actual room. That's how it works. Next up, the room temperature can be influenced by room influences if necessary, for example, an open window or the heater itself. The room controller records the temperature and sends the temperature again to the loop, and that's how the control loop is created. So we start the heating, it goes through the loop, we measure the temperature again, and we check is the set temperature the temperature we actually want. So there are actually various influences on how the room temperature in the room itself can be influenced. For example, the radiant heat from lighting, if you don't have automated shading. That's actually a very neat trick to reduce the heating cost in winter, but that's another topic of its own. Next up, if you have a lot of electrical appliances like a washing machine, like an oven, like a heater, like a dryer, this definitely will emit a lot of heat output that needs to be taken into account in individual room control. Next up, the weather conditions are super important, and the outside temperature also influences the room temperature depending on the building's insulation. All those factors need to be balanced and be put into the control system in order to keep the temperature normal and most importantly constant. This example shows another schematic representation of an individual room control system. This time we illustrated with one of our room controllers. It's illustrated with the Kala. So the Kala room controller compares the set point and the actual temperature and calculates the control value from this. For example, the actuating value is sent in percent to the heating actuator via the KNX bus. This opens and closes the actuator or the valve depending on the controller specification. As a result to this, the radiator emits its heat to the room. The room temperature is therefore always adjusted to the desired set point temperature. Once we increase the set point, for example, more water will go through the heating system and more heat will be emitted. So just to explain the visualization a bit, the red arrow shows the hot water flow to the radiator and the blue arrows show the return flow from the radiator. Okay, 1 second. I just see there a question popped up. Give me one moment to check it. Okay, so the question is the following. Can I set a minimum and maximum set point temperature where the system will work? So this is not possible to do on the controller, but it's possible to do in the ETS to set a range in which the user can actually change the set point, but this needs to be configured in the ETS itself and not on the room controller user interface. Thank you very much for the questions. I don't see any other open ones, so I will continue with the presentation. Next topic is the different control types. Let's discuss two-point controller. So the two-point controller is the simplest controller. It switches on when the temperature falls below the set point temperature and switches off again when the set point temperature is exceeded. I think we all are familiar with the very classic bimetal thermostats that you can see on the right-hand side. These thermostats are typically two-point controllers. In the example above, I have illustrated the function of the two-point control with a hysteresis. So the green line is our set point. We want to have the set point at 25 degrees. Very warm and cozy, right? The red dashed lines show the hysteresis range, so this is the range at which the thermostat switches on or off. We assume a hysteresis of plus minus 1 degree. This means that the controller switches the heating on when the temperature falls below 24 and off again when it exceeds 26. So if we look here at the yellow line, the yellow line is actually the desired temperature. So it sort of bounces around to the upper threshold and the lower threshold in order to be as close as possible to the green line as possible. There are better ways of doing this, and we will show you in a bit. So if you're setting the hysteresis in the two-point controller, there are actually two different options. The first option is the large hysteresis. So a few switch on and few switch off cycles of the heating valves is very gentle. This is very gentle to the heating actuator, for example. One negative consequence is the control is quite inaccurate, because if you remember the hysteresis graphic, it might go up not 1 degree plus minus, but 3 degrees plus minus. So it goes further away from the actual set point and it takes longer to go back to the actual set point, but there will be less switchings and less switch off cycles, which is good for the actuator. But with the problem, the control is inaccurate. How to do it differently? You have the small hysteresis. The difference is that you have many switch on and many switch off cycles. Therefore, it's not really suitable for heating actuator with relays, because they can just switch to a limited amount of time. The control hits the desired temperature more precisely. That's definitely a plus. We need to note that the valve also needs 3 to 5 minutes to open and close and may therefore no longer work properly if the hysteresis is too small. So you can go for a large or a small hysteresis, but in most cases you need to evaluate and probably find a way through the middle. Let's talk about one control that is a little bit neater than the two-point control. Let's discuss the PI control. So the functionality of a PI controller is so-called a continuous controller. For example, the actuating variable can assume any values from 0 to 100. In simple terms, that means that the continuous controller can not only switch on and off, but also sensitively adjust the actuating variable to the room difference, to the temperature difference in the room. In the example above, I have graphically illustrated the function of the PI controller and the continuous controller in the light blue line. So after the controller is switched on, the temperature initially oscillates around the set point and then moves closer and closer and closer to the desired set point as it progresses. Our room controllers, which we will get to know later, all have the integrated PI control. Let's discuss the advantages of the PI controller or the continuous controller. First of all, the controller regulates continuously. The desired set temperature is reached very, very precisely. On contrary, if you use the two-stage heating. Disadvantage: the setting of the controller parameters is a little more complex and it must be adapted to the used heating system. Let's have a look at the different heatings type and the recommended heating mode that we're having. So for example, if in the house or in the project that you're working on, you have a hot water convector heating, it is recommended that you go for a pulse width modulation or a continuous controller or a two-point control. Most is okay. What the pulse width modulation control is, we will have a look in a second. If you have floor and wall heating, you have a very inert system, and therefore the pulse width modulation or the continuous control with a long cycle time is most suitable for this heating system. Another heating system that is quite common is the hot water fan heating. In order to control the water circuit, continuous PI control should be used. So if a fan is switched together with the hot water circuit, the two-point control will be needed. Next up, we have the electrical heating for convector heating, for example. Here, you can use the continuous PI control. If you have the fan heating integrated also, then you need the two-point control. I'll make a super quick break and check for some questions that might have come up. I'll be back in 20 seconds. All right, no additional questions popped up, so I will continue with the presentation. As announced, now we will have a look at the pulse width modulation. The KNX heating actuator receives the actuating variable from the continuous controller and converts it into a corresponding pulse width modulation signal. In the following, we will take a look at how pulse width modulation works. For continuous control, it is necessary that the valve not only opens or closes completely, but that we can also control the valve in various intermediate positions. This is realized via the so-called pulse width modulation control. The valve can move to different valve position via the ratio of the pulse and the pulse time. Let's make a small example. If the ratio between the pulse and pause corresponds to 50%, as you can see in the GDN VCC line, for example, in the graph that is displayed right now, the valve is open to 50%. If you have a look, for example, at the 25%, then it's the other way around, and you have the 25%, same as with the 75%. So the pulse width modulation helps to have intermediate precision with the valves of the heating actuator. Next up, we will deal with the operating mode switch over for room temperature controllers. So most temperature controllers in the KNX field have so-called HVAC objects. HVAC stands for heating, ventilation, air conditioning, and cooling. That's probably old news for the KNX professional amongst our listeners today. This HVAC switchover can be used, for example, to lower the temperature on the controller display when a room is not in use. It is conceivable to lower the room temperature depending on the time, period, calendar, or for example, to lower the heating during school vacations. I think this is quite known, so I don't really want to present this chart. I rather go over the next one, since the older temperature controllers are often controlled with 3 1-bit values, as can be seen in the table above. So the operating modes can be switched by using the 3 1-bit values. In our products, you can select whether the switchover should take place via the 1 3-bit objects or the HVAC objects that we've shown in the slide before. So the values shown as X have no influence on the status of the operating mode. Let's have a look at how the operating mode switchover is actually working. So, as we all know, Energy consumption plays a major role these days. We don't just want to control the heating, we also want to make it smart. For example, we have the option of switching the heating on when people are present in the room and lowering the temperature when they are absent. Another option is to lower the heating when the windows are opened, so we don't put all the warm air out of the window. Otherwise, we could also just throw money, heating money out of the window. Next up, we can set the HVAC operating mode or the priority 2 on the left-hand controller. If the window contact in the room is closed, the detector remains in switch position 0 and no higher priority than HVAC1 control is executed. In this setting, the HVAC2 manual setting operation mode is executed by the controller. So if the window is now opened, the window contact switches to the operating mode, for example, frost or protection mode. If you remember beforehand, you have different temperature threshold for the different HVAC modes. So for example, the comfort mode could be set to 25 degrees in the room, and the frost or building protection mode could be put down to 12, 15, 16, 18 degrees, something like this. So if the window is opened, we want to change the set point of the temperature with the mode switch over from 25 to a much lower temperature in the frost or protection mode. As a result, the present operating mode on the heating controllers is decoupled and therefore no longer active. If the window is now closed again, the operating mode of the manual setting on the controller is called up again, and we should be switching back into comfort. Let's have a look at this schematic diagram of a real intelligent individual room control system. So in this example, we show the Kala room controller. This room controller compares the set point and the actual temperature and calculates the actuating variable from this. The actuating variable is sent to the heating actuator in percentage, and this opens and closes the actuator or the valve depending on the specification. The Kala also has a binary input which can be used to integrate a window contact into the control system. The heating can use this window contact to lower the temperature to frost protection mode when the window is open, for example. The heating control can also be controlled smartly via a presence detector. Here, for example, the heating could be switched to comfort when present and lowered to standby when absent. This is conceivable, for example, in classrooms, offices, etc. This will save a lot of energy in the long run. Let's have a look at the two-stage heating. It is actually the combined heating of two different heating systems. Most of the time you have one heating system that reacts very slowly, like for example in underfloor heating, in combination with additional heating system, like for example a wall heater. Okay, so you have one very slow one, for example the underfloor heating, and in order to reach the desired set point temperature, as displayed here in the bathroom, quicker, so you use the whole wall heater also, so you activate two-stage heating in order to reach the desired temperature as quickly as possible. As promised, we're going to have a little overview of the Elsner room controllers. I will go over this quite quickly since this is supposed to be an educational webinar and not a very salesy one. Just an overview of the room controllers where we have the control that we mentioned beforehand. Okay, first up, one of my favorites, the KNX ETR 101. It's a very simple room controller with a very clear usability. You have the plus and minus to change the set point. It's also available with binary analog input, so you can also connect, for example, an NTC for underfloor heating control, a window contact, etc. The creativity is up to you how you are actually using it. Another one from this series is the ETR 208, which also has the integrated temperature measurement, temperature control, but it can also switch and dim lights, sunshade, and windows. It's quite a complete room controller on the lower pricing end. Next up, we have the KNX ETR 102 fan coil with the integrated temperature measurement, temperature control, but you can also control the fan level control. All room controllers displayed are with a real glass surface, so you can also clean them, for example, with heavy disinfectants without being too worried of destroying the touchscreens or similar. Real glass surface with a very, very low installation height, so it's a surface mounted and a frameless series. You can see here it looks quite nice when it's on the wall. We also have the switching series, the M series, for example. This is our very simple room controller. Let's move on to the more complex ones. Here, for example, we have the Kala series, also with the integrated temperature measurement, temperature control. We can switch and dim light, sunshade, and window control, and we also have 4 binary inputs. What's special about this one, we have several versions. So we have this one with a temperature controller, temperature sensor only. We have one with humidity, and we have a very complete one with temperature, humidity, and even CO2 measurement. The Kala series fits perfectly into the 55 by 55 system. We have the touch panels, but also the very simple thermostat with the plus and minus that works with all of the common 55 by 55 frame systems. Next up, we have the Kala KNX Multitouch T-Light and Sunblind. I like this one quite a lot because in some office applications, I think I speak from some experience, you always have some special customers that really like to see, okay, is the changeover really 1 degree or just a half degree? In order to avoid that, we have visualized the set point change in 3 steps with LEDs. So you can see on the bottom row, you don't have the 7 segment where you have 23 degrees point 2, but you have the 3 different set points that you can put to increase the heating and to lower the heating. This is how the Kala Touch can look like when installed on the wall. I heard that just a question came up. One moment, please. Okay, there has been the question if there's weekly schedulers too in the Kala. Yes, there is. There's timers integrated into the ETS. I have 2 more questions. Just give me 1 second to check, please. So there has been a question about one of the last room controllers that I showed, the multi-touch. I will just go back very briefly because I think this is quite a interesting question. If it lets me. Yes, it does. So the question has been there if you can change the steps in the Kala in the last one. Yes, you can change the steps, how you can change the set point in 0.2, 0.5, or 1 degree steps. This can be set, for example, in the ETS. I hope that has answered your question. If so, I just realized I'm a little bit slow with the time, so I will continue with the presentation. All right, next up we have another room controller from our series, which is the Nunio. It has the integrated temperature measurement, we have the temperature control, we can switch and dim the lights, we can use the sunshade and the window control with this one. We have 1 display page that we can configure as a single, double, triple, or quad push button that you can see on the arrow on the top left side where you can go to the push button page, and on the other page you can set up a display for the temperature and the set point adjustment. Plus you have the fan coil control, and you can also do a manual changeover of the HVAC objects. Also, it's more on the cost efficient side when it comes to pricing for KNX products made in Germany. Let's have a look at the practical examples. So in this section, I would like to have a look at how easy it actually is to configure a KNX heating control system in the ETS. Let's talk a little bit about the first example that we want to do. So we are located in the living area and we have a KNX ETR 101 heating controller, and we want to connect it to a window contact and a heating actuator. Okay, how to do that? I have pre-recorded a quick video that I will play in one moment.
All right, in the next use case, I want to have a little bit more detailed look into the PI control, and I also would like to implement a window contact for the mode changeover. Let's get into it. First, we got to activate the temperature PI control. For implementing the window contact later on, we need 3 1-bit objects, so we're going to do this setting already. The mode after reset, I would like our controller to start in the standby mode after a reset. Next up, I would like to change the increments in which we can change the temperature. So 10 is 1 degree and I would like to have it in a half degree. So I'm gonna put a value of 5 that you need to multiply with the 0.1 to get the actual increment for the changing of the nominal value. Okay. Also, we have set here the sorry, 1 second. We have set the separate. This is the default value, which we're gonna need now also. So in the standby value, I would like to have a value of 20 degrees. Hence, I'm gonna put the 200 here. The minimum and maximum object you can set from 16 to 28 degrees. In the echo, I would like to have 16 degrees. This is okay. We can also put 17 degrees, so you can just see the change over. Next up, we're gonna have a look at the inputs because we need to use one input of our ETR 101 BA2 for the window contact. Hence, we're gonna activate the yes, go on the first input, and we set the function of a switch. That's correct. And the telegram, first we gotta send 0 when pressing the button, and when releasing the button we want to send a 1. That's all we gotta set in the parameters, and next up we're gonna have a look at the group objects that we need to link. First up, we're gonna use our current temperature set point and we're gonna link it to the group address of the current set point. First one done. Next up, we're gonna use the control variable heating level 1, which is an output, and we're gonna connect it to the group address 002, the control variable of the heating. Next up, we're gonna take the mode control with the echo and standby mode, and we're gonna connect it to our group address of the mode control, echo and standby. Lastly, we're gonna use the push button and connect it to the last group address as well. And here we are. So if the window contact is activated, meaning the window is open, it will go from the standby mode in the echo mode and lowering the temperature, allowing us to save some energy with a really smart heating control.
All right, that has been the presentation of the first use case. As you can see, I don't use the ETS too often. I'm still a little bit slow with connecting the communication objects. But Yeah, I'm getting there. So at this point, any questions about the parameterization in the ETS, about the use case that you have just seen? I've seen another question popped up about the thresholds and the combination of a probe and the underfloor heating. Since this is quite a detailed question, we will answer this one in writing and not answer here. If there's no additional questions, I will move on with the presentation and the next use case. So I really like this one. We have an office space and we have the heating control with the Kala, for example. And we have one main controller and we have one extension unit that is placed in different parts of the same office. Excuse me. And yes, how to actually do that is quite simple and pretty straightforward. And I will show you in the next video I have pre-recorded for today.
All right, so let's have a look at a very neat little use case. So in the following example, we would like to set up the temperature control in an office setting. What's special about that? As you can see, we would like to use one main controller and one secondary controller. So you have two controllers in the same room where you can set the temperature. How to do that? First off, we start in the menu and we activate the temperature control. Next up, we go on the temperature control and allow the mode selection so we can see our different HVAC objects. At this point, we also can set the name of this controller to office. Next up, we're going to go in the temperature PI control and we activate this one also. As you can see, there are many settings, but for this use case right now, we don't really need them. So I will leave them as default. So we're just gonna do the use case how to set up a main controller and a secondary controller. Okay, main controller is actually done. So we can switch over to the secondary controller where we start in the menu again. We activate the temperature control. We click the temperature controller to allow our mode selection so we can see our HVAC objects. Before I forget, we also need to set up the name again. We can use office as well because as explained, it's gonna be in the same room. Next up, we're gonna activate the temperature PI control. And here, this is very important, we gotta set this controller as a controller extension because this is the secondary controller. We are done with the parameter settings and we can move on to the group objects and the linking of the group objects, which you can simply do via drag and drop. First up, we're gonna set the HVAC prior 1, HVAC prior 2, the set point of the comfort heating, the set point plus minus, and so on. I will do this real quick and then we can move on to the next topic. The echo heating, echo plus minus, the status of the heating on and off, and the comfort extension status we're gonna set to the comfort extension. Secondary controller is linked and we can switch back to our main controller where we gotta do pretty much the same thing. We're gonna start with the HVAC prios and link the group objects and link the group objects once more. The heating actuating variable we need in this one, and we only need the status Status of the heating. And the comfort extension, and we are also done with the linking of those group objects. Okay, so we are done with this one now that we have linked the group addresses. So what have we done exactly? We have set up two different controllers that are located in the same office. This allows you, for example, to control the temperature in one end of the room, and the set point is going to be taken over by the other controller as well. This is quite a neat little use case for the use of our Kala series or of our temperature controllers in an office setting.
All right, one question popped up already, and this question is, what is the difference between HVAC priority 1 and HVAC priority 2? So let me give you a quick example. So basically, as it says, the HVAC priority 1 is more important than the HVAC priority number 2. Let me give you an example. For example, if the HVAC prior 1 is connected to a window contact and the window contact says window is open, don't heat right now, and the HVAC priority 2, for example, is a timer that says start the heating every morning at 8 a.m. and the window is open, then HVAC priority 1 is more important than HVAC priority 2, and HVAC priority 1 will be fulfilled and HVAC priority 2 won't be fulfilled. I hope that makes sense. Let's move on to the next example. So here we have our Colo Touch, and we would like to set up the temperature control that is quite nice looking, and also how to connect it to the mobile app in our high-end room controller. I have prepared another video for you. I'll just play it.
All right, now we're gonna have a look at another super interesting use case with our Colo Touch. What do we want to do? So we would like to set up one temperature control page. We would also like to activate the app control, and we would like to add an external NTC so we can measure the room temperature in the corresponding room. Let's get into it. First up, we're gonna set up the page itself. We're gonna go on page 1 and we're gonna change the page name to heating. Next up, I really like our rotary control icons, so I'm gonna choose the 32, the symbol number 32 with the rotary control. The rotary control is supposed to be controlling the set point, hence I named this one set point. Next up, I would like to have one side of the rotary control in red and one side in blue, so I can see when we are in the heating and when we are in the cooling section. That we can do with the symbol 71. We're also gonna set the minimum value to 19 degrees and the maximum value to 25 degrees. Our resolution we want to have in 0.5 degrees steps, so we're gonna put a 5 here. Our start value is 20 degrees. We want to put the name indoor temperature, so we put this on the language 1. Next up the function, we need a display 16-bit floating point, and the text for our unit is degrees, since we want to display the degrees of the heating system. Next up, the last symbol that I would like to have, because we're talking about the indoor temperature here, I would like to use a house with a thermostat in the middle displaying indoor temperature, and this is our symbol 163. Okay, let's have a look at the automatic section. First up, we're gonna activate the send automatically. Next up, we want to have a temperature controller. We have this activated so we can go in the automatic one settings. Here we do not really need to change anything for this example, so I will just leave the default settings for now. Let's have a look at the input. We want to activate the input 1. We go on the input 1. And as mentioned in our use case, we would like to use an external NTC. So we put temperature sensor NTC as the function. And that's what we got to do for now. That's all for the parameters. Let's have a look at the group objects. Since our Colo has quite an extensive application, you can see there's a lot of objects you can use. I'm trying to really only focus on the one we got to use for our use case. First up, we got to start with the page 1 with the rotary control, which we're gonna put on the group address of the set point. Next up, we're gonna have the object 632. Let me to 634, which is the nominal value and the standby, which we're gonna put on the same group address of the set point. Next up, we're gonna need the variable for the heater in the first level, which we're gonna put on the variable heater as well. Next up, we have the temperature sensor that we just activated in the input section in the parameters, and we want to have this value as the indoor temperature. Hence, we link it to our group address 001. We are almost done here, just a couple objects more. We need the automatic inside temperature and the measured value, which we gonna link, to our indoor temperature as well. And now the last object we gotta work with is the object of the surface itself, the symbols that we used, and we're gonna connect this to the first group address as well. Now we are done with the linking of the required group addresses, and we can move on to the last step. Just a quick reminder, we want to set one heating page for our Colo Touch. We want to implement an NTC, and last but not least, we want to activate the Wi-Fi settings so we can control our thermostat with our application for the Colo Touch as well. Therefore, we're going to activate the use of the Wi-Fi. We're going to put our network credentials. And next up, you need a phone that you can download the Colo app. It needs to be in the same network, and as easy as that, you can control our temperature page that we just set up in the ETS via your phone as well.
All right, we are coming to an end of today's webinar. Do you still have some questions about the parameterization in the ETS, about the use cases that we discussed? If not, we can already move on to the next one. I would love to hear your wishes for future webinar suggestions. What can we do better? What was good? What was not so good? Of course, everyone likes a compliment, but I'm even more interested in the things that we should be improving for our next webinar. I will remain in this call for another couple minutes to see if there's other questions coming in. One more information, everyone that has been attending this webinar, we will send up a short little feedback form. It's just a couple questions and a blank field where you can also give us suggestions. It would be more than amazing if you could give us some feedback on how happy you are with the Elsner Academy, if we're on the right track, if you're missing something, more of this, that, less of that. Please give us your blunt and honest feedback. We need it to becoming better and offering the best services with Elsner Academy that we can do. I'll check for questions real quick. Okay, there has been a couple questions. Those are quite complex, so we kindly ask you for a little bit of patience. Our technical team will get back to those inquiries and send you an email with the requested answers. I see there's not much more questions coming up, and the first attendees are leaving today's webinar. I will still stay for a couple while. Okay, one interesting question. If the colo, there is a subscription to use the Wi-Fi pages on an app, if I understand the question right, if you have to pay for the use of the app, of the colo app. No, you don't. It's part of the colo itself. Okay, I thank you very much for the interesting question. I especially loved about today's session that it was very interactive. There has been a lot of questions. Some we have answered in the background. Some I tried to answer during the webinar. I actually planned to do the webinar in 45 minutes. Now we took 58 minutes. I hope that is still okay for you. I thank you very much for attending and for the feedback. And I hope to see you in the next one and wish you a most successful week and hope see everyone soon. Take care. Bye bye.